Welcome back, Physical Science 20. So we looked at this precipitate chart in the last video, looked at how that all comes together. So now we'll look at doing an example here shortly. So selecting a reactant to produce a precipitate. How do we treat water contaminated with toxic metal ions? We can precipitate the ions out of solution. The solubility table can help us choose an appropriate reactant. We want the reaction to produce a compound of the toxic metal that is only slightly soluble, because slightly soluble means that we will get a precipitate, or in the solid form. So we will get two ions, a positive and negative ion, come together and they form a solid in solution. The toxic ions then form a precipitate and can be filtered out. Sometimes two different reactions are used, one after the other. To remove a range of metals, chemists select an ion that forms slightly soluble compounds with as many metals as possible. In practice, soluble sulfide compounds are usually used because if we look on that chart, sulfide forms a precipitate with a lot of positive ions. Chemists can also selectively precipitate certain cations from a mixture by using different solubilities. For example, the solubility table shows that silver chloride is slightly soluble, but copper 2 chloride is very soluble. Therefore, adding sodium chloride will precipitate silver ions from a solution containing both silver and copper 2. So we'll look at an example here. So will a precipitate form when these solutions are mixed together? We have potassium chloride and silver nitrate. If there is a precipitate, write a chemical equation. If it doesn't make a precipitate, then we could consider that to be no reaction. So if we look at our periodic table, potassium is K+, chloride's 1-, silver is +1, and nitrate is NO3-. Okay, so that's good. It's all going to be 1 to 1. So here's where we're starting off. And you would take a look here. It's like, so we start off with potassium chloride, aqueous, and silver nitrate, aqueous. So what that means is that if I had solid KCl thrown into water and AgNO3, the aqueous form means that it's basically dissolved. So you see potassium ions floating around, nitrate ions floating around, silver ions, chloride. So all of these are floating around. And then so potassium was with chloride, gets a potassium chloride, silver with nitrate. So of course you're looking to see, well, does potassium and nitrate, do they join up together and become a precipitate? Or silver and chloride, do they come together? So what we're looking at is all the different combinations. So we're going to be looking for potassium and nitrate, and then silver and chloride. So let's look at potassium and nitrate first of all. So if you recall, nitrates are interesting because nitrates with every positive ion are aqueous. There are no exceptions. If there's a nitrate present, there will not be a precipitate. So if I'm looking at potassium nitrate, it's just simply going to stay as AQ. If you look at silver chloride, so again, we look at chloride first of all, so the negative ion of chloride, and most things with chloride are going to be aqueous, no precipitate, but I have to look at the exceptions. Oh, there's silver. So silver with chloride, when there's silver present, PPT, precipitate. So AgCl, and that's going to be a solid. And I don't have to balance anything here because they're all 1 to 1. So we wrote the chemical equation. Everything remains dissolved except silver chloride. And if you look at the diagram here, or the picture, you can see, there it is. Silver chloride comes together and makes a solid on the bottom of the beaker. And potassium and chloride, potassium, this should be a nitrate actually. Mistake in the picture. NO3. AQ, it remains floating around. So potassium and nitrate remain floating around, but silver chloride sinks to the bottom, and that is considered to be the precipitate. So that's how that chart works. Let's look at another example. All right, so let's see here. We have, will a precipitate form when we have potassium sulfate and iron 3 chloride together? Okay, so we're going to look at that, see what happens with that when I have that combination. So again, take a look at your pink periodic table booklet so we can get the charges of each of these. So potassium is K+, sulfate is SO4 2 negative, iron 3, of course we know that's Fe3+, and chloride. All right, so let's put these together. So obviously here, if this is 2 negative, I'm going to have 2 of those potassiums, K2SO4, and over here, iron 3 chloride, so this is worth 3+, this is worth 1-. So I'm going to have 3 of these to make that a combination. Okay, and again, so we think of all of this in a beaker, and we're going to see, will potassium and chloride, will they form a precipitate? Or iron and sulfate, will they form a precipitate? So that's what we're going to have to look. So let's look at potassium and chloride first of all. Potassium and chloride. So chloride, there it is. With potassium, could be over here. If potassium falls on the default side. Do I see potassium here? No, no, nope. So potassium is one of the ones that will be aqueous with chloride. So I know potassium, K+, Cl- is just aqueous. And then iron 3 sulfate. So iron 3 sulfate. So sulfate, here it is with iron. So it could be on this side unless iron is an exception. No, it's not. So iron is on this side here. So Fe, let's see here. So iron sulfate 3, 2. So of course I'm going to have, let's see here. I have 2 iron and 3 sulfate. But guess what? We don't even have to do this. 2, 4, 6, 3, 6. We don't have to do this because guess what? This is actually no reaction because notice we don't have a precipitate. Not a precipitate. So it's just like nothing has changed here. Aqueous, 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 aqueous. Aqueous, of course, just simply means that we have K+ is floating around. Sulfate ions floating around. Iron 3 chlorides. So there's no reaction here because we don't have a precipitate being formed. Okay, so no reaction. Let's look at the next 3 here. You may want to pause the video and just try these yourself. Then come back to this video. Which of the following combinations results in the formation of a precipitate? Write the balanced equation. If there is a reaction, if there isn't, write no reaction. So you may wish to pause the video and try these, or if you've already done so, we'll look at these. So let's see here, sodium and nitrate. Now what I like to do is I like to write what the charges are. Sodium, of course, is Na+. Sulfide is 2 negative. Nitrate is -1. And I did that one first because look at 2 nitrates balance a lead. So if I have 2 of these, that's 1 negative, 2 negatives. And if I just have 1 of the positives, that must be lead 2. All right, so let's look at changing partners here. Now, right off the bat, you know that sodium nitrate is not a precipitate because nitrates with any positive ion is aqueous. If I look at lead and sulfide though, sulfide with lead, sulfide with most things is a precipitate unless lead falls over here. Now lead is not a group 1, that's the hydrogen, sodium, lithiums. The group 2 ions are the calcium, magnesium, barium. So well, guess what? Sulfide with lead is going to be a precipitate. So I can go ahead and write the equation here. So sodium nitrate +1 -1, that stays as aqueous. Lead 2+, 2 negative. So they come together just 1 and 1, and that is going to be the solid. PBS. So just have to balance this now, and that's the solid. Let's see, 2 nitrates. So 2 nitrates. It's also going to give me 2 sodiums. 2 sodiums. It's good. All right, let's look at the next one. So here we have, okay, so we have chloride, and we have, oh, the ammonium ion. Yes, NH4+. We have potassium, and we have sulfate. And of course, just break them up into ions. Of course, that 2 is required there because, yes, we have 2 potassiums with every sulfate. Let's look up ammonium sulfate. Sulfate with ammonium. Sulfate with ammonium by default is in this area, unless, of course, ammonium is an exception. Yeah, no exception. So ammonium sulfate is aqueous. That means it's just dissolved still. And what about potassium chloride? So chloride with potassium should be over here, unless, of course, potassium is an exception. It's not. So potassium sulfate is AQ. So since both of them are going to be aqueous, that means no reaction. So check it out first. Don't bother. It's like over here I started writing the equation and realized, oh, there's no reaction. So nothing to worry about there. The last one here, iron and carbonate we're going to look up, and sodium and chloride. So over here, chloride is always -1. Now since I have 3 of them balancing one of these irons, it must be iron 3 I'm dealing with. Carbonate is 2 negative. Sodium I know is +1, so that explains why I need 2. Right, so let's look at sodium chloride, good old table salt. Good old table salt. So chloride with sodium would be aqueous. Unless sodium is over here, it's not. So sodium chloride just simply dissolves. And we know that. Table salt. Iron 3 carbonate. Carbonate with iron 3. Carbonate with most things is a precipitate. Let's see, iron. Is it an exception? No, iron's not a group 1, and it's not ammonium. So guess what? Iron carbonate is going to be a precipitate. So to bring iron and carbonate together, take a look. So 3 plus, 2 negative. So yes, we know what we're going to have to do here. Lowest common multiple of 6. 2, 2, 2, 2, 4, 6. 3, 3, 3 plus 3 is 6. So I need to have 2 irons and 3 carbonates. And that is the solid. And then sodium chloride, well, 1, 1, plus 1, minus 1, that's just NaCl. Aqueous. Then I just have to worry about balancing this. I need 2 iron here, so I'll put a 2. That's going to give me 6 chlorides. So 6 chlorides. 6 sodiums. Here I have 2 sodiums, so I'm going to have to put a 3 in front to make 6. And then 3 carbonates. Ah, there we go, 3 carbonates. So that is balanced out. Iron 3 carbonate is the precipitate. All right, so that's how that works, ladies and gentlemen. So what we'll do is we'll stop the video there, then we'll come back and look at neutralization reactions.